Welcome. We're going to do the multiple choice questions, so make sure you try these out on your own. Definitely read through all these questions. It's just 1, 2, 3, 4, 5 questions. That's it. Number 5, 6, 7, 8, and 9. Okay, so we're going to go through these. And make sure you take notes. I have definitely a handful of notes. It doesn't have to look exactly like mine, but definitely add things to your paper and another piece of paper to get full credit. Okay, so the first question says the same fact scenario for these two questions. And it says a researcher wishes to compare the average amount of time spent on extracurriculars. They talk to an SRS of 60. Okay, so N is 60. And those were in the suburbs. They found that the mean time, so that is your X bar, the mean time of that sample, and I'm going to continue reading, to be 6 hours with a standard deviation of 3. Okay, so S sub X is 3, and the average amount out of the 60 kids they asked was 6 hours. Now, they also did an SRS of 40 kids in a city, not a suburb, and found the average, the mean to be 5 and the standard deviation of 2. And they talked to 40. Okay. So there's our information, and we want to find the difference, if there is a difference between the two, because it says, suppose the researchers decided to carry out a significance test of H sub O of a two-sided. Okay, so if I take that and I subtract it, so the difference between these two is 1. Okay. Now, H sub O, we have to assume that there isn't a difference between the two, and they actually are telling us this is a two-sided, meaning we had no hunch that maybe the suburban would be more or the city would be more or less. So they're basically saying H sub A is there just something other than one another. The mu of the city is something other than that. Okay, so this is exactly what your calculator would do, and it would calculate the test statistic. And you might want to just glance at this formula sheet. It might be handy when you take the test. The test statistic is the statistic minus the parameter over the standard deviation of statistic. So here we already calculated our test statistic is there a difference? So we found a difference in our sample of 1, but is that statistically significant enough of a difference? So if in fact we assume that's 0, they got a difference of 1, and what would be the probability of that outcome if in fact there was no difference? That's why we need this t value. Now, I know it can't be z because they did not tell me the standard deviation of the population of either of the schools or the overall population of the school or of the city in the suburbs, nothing like that. So when I look here on my paper, I think about this formula and I think a standard deviation of statistic, if it's two samples, and it's definitely a difference of a sample mean, this doesn't apply. It almost never applies. These are not equal because maybe they could be equal, but we were not given the standard deviation of the population. So we definitely have to go here, and we also have evidence that their standard deviation is something different because the information we got is that 1 is 3 and 1 is 2. Okay, so that formula is what we're looking for in the denominator. The statistics we got was 1, and our parameter is our H sub O. What are we supposed to assume is correct? So here, that's exactly what we see there. We get a number 1 minus our H sub O. Our parameter we assume is 0. And we put that all over the standard deviation of the first one over N1, the standard deviation of the second one over N2. And that's exactly what they have here. So hopefully you circled answer 8. If you have more questions on this, let me know. Now, continuing on, they actually calculated a p-value. So I went to the trouble of actually figuring out what that number would be, and I got the number 2. So that's pretty extreme, isn't it? 2 standard deviations away from the mean. It was a pretty shocking number. And you might be thinking, But this is a T, not a Z. So if you look at a Z table, see how, a negative Z would actually give you, see that number 2.28. So that means that there's not a whole lot of area to the left of -2 standard deviations, and not a lot of area to the right, because that's going to be symmetrical. But so what does the calculator actually do? And that, I think, is important to kind of understand. It actually approximates this curve, and that's a T. It's not quite a Z yet. So we had two values of n, and you're going to subtract one as well. We had 60 and 40. So your calculator has a fancy way of figuring out somewhere here, and I don't know exactly where, it's going to calculate what would be the probability of that. So see this number 2. Basically in here, the probability is somewhere around 0.025. Pretty darn close to what we got off the Z table, isn't it? But it's a little bit more conservative, okay? But so we're going to presume that the calculator did it in its fancy, fancy way, and it's actually did it and calculated to the left was half of that, and to the right was half of that, because this was in fact a two-sided test. Okay, so if you get that though, if you are in fact at the 0.05 level, which we totally are, that number's less than that. So because of that, that's such a rare outcome, even if we assume that there is no difference between the schools, that's rare enough that we do have sufficient evidence to show that there is a difference. So we have to reject the null hypothesis. So our answers are now down to here. Since we've rejected the null hypothesis, we do have convincing evidence that there is a difference between the schools. So definitely I'm going to have to go with E. Let me know if you struggled with that or you want that described one more time. Okay? Next, pretty neat. We see here that at a baseball game, there's 42 out of 65 who own an iPod. So I could